Hey, one thing that I just realized that I screwed up on that last page was that your variance here is going to live between, we got n minus 1 times s squared divided by, and then n minus 1 times s squared divided by. I actually wrote it as chi squared over the chi squared, the left chi squared, this should be the right. If you think about y, we'll talk about that here in just a second, and this is on the left. You guys, this is a bigger number, remember? If I go back, this is a bigger number, so it's clearly going to produce a fraction that's smaller. This is the smaller number, so it's going to produce a fraction that's bigger, clearly. I apologize about that. I also wanted to make sure that we make mention is, especially for what we're going to use, these for, what we really want is we want sigma. Well, I'm not afraid. If this gives me the confidence interval for sigma squared, then I just got to take the square root of everything. So I end up with the square root of n minus 1 times s squared divided by chi squared on the right, because it's the bigger one, and this is the square root of n minus 1 times s squared over chi squared on the left, because it's a smaller one, so I'm going to produce bigger numbers. All right, but just like everything else, I want you to have this aching suspicion that you're not meeting assumptions. Assumptions. All right, the assumptions for being able to build a chi-squared, what am I saying? A confidence interval around variance and thus standard deviation, which is what we're really interested in. The first things first are, it's got to be an SRS. In other words, when you gather your data, it's got to be a simple random sample. So you got to go and you got to randomize, randomize. That's our mantra pretty much too. And this is probably the most limiting one. Is the population has to be, it's got no choice, has to be normally distributed. If it isn't normally distributed, we can't use this technique. We have to use far more complicated techniques. All right, and this is an intro to stats class, so we're not particularly worried about that. But the population has got to be normally distributed for us to even be able to talk about this. All right, now I'm going to walk you through just really quickly. I'm going to walk you through one of these problems because really it's computational. It's difficult to do on a calculator or on a computer unless you have programs that are geared specifically for it. So let's just real quick go through this guy. Let's say that I'm not even going to try and make up a story for it. Let's just watch what happens. I'm going to collect 10 data samples, 10 data values, all right? And let's just say that my standard deviation ends up being 3.5, all right? That's my standard deviation. Or wait, I'm sorry, that's my variance. All right. I know that if n equals 10, then the degrees of freedom is equal to 9. I need to slow down because I'm starting to say silly things. All right. Now, I'm going to build one of these confidence intervals out around the variance. And then when I'm done with the variance, I'm going to get to my standard deviation. All right. Now, but let's talk about this for a second because I want to make sure that you all get this. I'm going to build a 95% confidence interval around sigma squared. Now let's remember just real quickly in case you got up and had to go to the bathroom or whatever. Remember, these form this chi-squared, or it's an F curve under some very specific circumstances. Now, the idea behind the confidence interval is still the same. In other words, when I find this chi-squared left and I find this chi-squared right, the probability or the area underneath this thing is 0.025, and the area under this guy is 0.025. The area under the whole thing is still 1. The problem is the asymmetry doesn't allow us to do that fancy schmancy that z alpha over 2 or t alpha over 2. So we have to use a different process. All right, so what we're going to do is we got our n. Notice the formula is actually really simple. You need n, you need s, you need chi-squared. So when we're doing one of these guys, we're going to do chi-squared left, and we're going to do chi-squared right, and we're just going to dig them out of our formulas. So bear with me here for just a sec. I have this cool little drawing right here. I'm going to do it actually on both of the tables just so you can see it, and this won't take very long. First thing that you want to do is identify your degrees of freedom. So there are my degrees of freedom again. Now remember, if I'm doing 95% and this is 0.025, this table reads to the right of the critical value. So if this is 0.025, then everything to the right of it way out here is 0.975. So I stumble onto my chart. I go down to 9 degrees of freedom, and I end up with, what do I end up with? 2.7. All right? Now, it's easy when I'm over here. I know this is also going to be 0.025. So I go over, because my chart reads to the right, 0.025 degrees of freedom. I cruise over to here, and I get 19.023. So this is 19.023. And again, those of you out there might say, wow, Ripley, those are big numbers. Well, remember, they're variances, so you've got values which are squared. Let me change back here. Now, all that I have to do is throw this in my formula. I know that sigma squared is going to live between n minus 1, hey, is that degrees of freedom again, right? 9 times 3.5 times 3.5 divided by the big number, because I need the small value to be on the left-hand side of the interval, 19.023. And I need the big number to be 9 times 3.5 divided by 2.7. That's why I'm dividing by the smaller number. And then I'm going to throw this guy in my handy-dandy. Let's see, 9 times 3.5 divided by 19.023. And I end up with 1.66 less than sigma squared is less than the second entry, and divide by 2.7. 2.7, and I end up with 11.67. All right, and we would write this, if I wanted to write a confidence interval, I would write this as 1.66 to 11.67. All right, now, but really what we're interested in, remember, the standard deviation. All right, so I know that sigma, according to this confidence interval, I know that sigma is going to be, what, square root of 1.66? Just throw that in, I get 1.29. 1.29. And if I take square root of 11.67, I end up with 3.42. All right? My standard deviation in a 95% confidence interval is going to be between 1.29 and 3.42. I can be 95% confident. If I do this a whole bunch of times, I'm going to end up with these values. Now, what happens if I want to be more confident? What happens if I want to be 99% confident? All right, let's go through that just real quick. All right, so we got the same thing. Lost my dingle here. All right, n equals 10, df equals 9. I want to be 99% confident. All right, just humor me for a sec. All right. So, ooh, they're getting better, aren't they? They're getting prettier. I just shouldn't draw this part. Now, in this case, since I'm 99% confident, then what I'm going to have here is a 0.005 and a 0.005. So, let's change colors again. When I do that, when I go to start looking for this chi-squared to the left value, then this is going to be 0.995. Okay? So, let's do that real quick. If I hop out of there and I go to this, let's see, if I go to 0.995, notice how they set it up, because sort of the union standard is for us to either have a 99, a 95, a 98% confidence interval, et cetera, et cetera. So I know that chi-squared on the left is going to be, for degrees of freedom, 1.735, 1.735. And chi-squared, I should have done the fancy chi-squared on the right, is going to be for 0.005, 9 degrees of freedom. Look at that. It's 23.589. Now remember, over here, let me go back here. I'm not going to go through the whole painful process, but look. Chi-squared left there is 1.73. Chi-squared left here is 2.7. So what I've done is I've shifted down, just like you would expect. I would also expect, if I wanted my confidence interval to be bigger, right? Remember, the more confident, the bigger the interval needs to be. I would expect my chi-squared right to shift up. Well, I went from 19.023 to 23.589. All right. Enough of confidence intervals. In the next chapter, we're really going to put everything together, and we're going to start being able to test stuff. We're going to be able to start calling people liars. Well, with a 95% confidence level. I hope you enjoyed. This is I love this little string of sections, because they're a lot of fun and they get really, really useful. Okay, so I'll see you in the next.